Okay, so my first, the earlier video paused in between because there was some interruption, so I'm very sorry for that. So taking ahead from where we stopped, that if you can recall, we have already done with this equation, different types of equation, notation, we have seen Leibniz, etc., advantages of notation. Now we are coming to what is called what is differential equation, and we'll look into different types of differential equation, and then we will end the video and go further into the next video. So if you see, what I have done is that I have drawn a diagram. In general, differential equation is divided into two parts. One is the ordinary differential equation and the second one is the partial differential equation. So when I consider what is called an ordinary differential equation, if you have seen this particular chart, you will see that this one, which has got a double value x plus y, or this or even this, up till this, these all things can be considered as an ordinary differential equation. That means it has got just two values, x and y. So this is what is called an ordinary differential equation. Now if we come to partial differential equation, we include further values that can be x, y, z, t, anything, which I will show you further. Ordinary differential equation is further divided into four in general, but there are other divisions which goes into advanced mathematics. So linear, separate, homogeneous, and exact. Right? So linear, separate, homogeneous, exact. We are not going to solve for those equations, but we are just going to see what actually these equations are. Now, if I just wanted to show you that what is a differential equation, then we can just note that an equation where a derivative is involved is called a differential equation. So I'll just try to give you a kind of a very simple example of an ordinary differential equation, how it looks like. So if I can just write a ordinary differential equation, so it would be something like this. I can write dy by dx plus y equals to 0. Right? So this is a kind of a very ordinary differential equation. ODE we generally call it. Why ordinary? Because you see we have got just two variables involved, x and y. Right? So with respect to x, we are trying to find out the values, function, we are trying to find out what we call the function, etc. Now if I say that what is a partial differential equation, then what I can write over here, so let me draw a bar so that you can understand. This part is what is called a ODE, or ordinary differential equation. So what I can do is that if I write, say for example, x of dy by dx, right, plus I include dy, but over here what I'm going to do is that I'm going to include another variable which is dy by dt equals to 0. Now you see that there are three variables involved, x, y, and t. And that is the reason that we call it as partial differential equation, or PDE. So typically in this kind of a partial differential equation, we include three values, x, y, and z. So there are three values, and we do not denote this like this. No, we denote it by a curvy d, right? So in general, for a partial differential equation, it just looks like something like this. So what you can do is that you can say d squared f divided by dx squared plus d squared f's divided by dy squared, and then we can write d squared f divided by dz squared, right, equals to 0. Right? So this, what we are doing, that we are differentiating x, y, and z, keeping this part constant. Right? So here we differentiate with respect to one variable, keeping the other variables constant. So x keeping f constant. So this is, we will show later that what is actually partial derivative and how we can find out those further orders. So now if I take, I will come to the ordinary derivative, but if I take a partial derivative, if I say it's PDE, so partial derivative can be further divided into a first order, we can see a second order, and we can see a third order. Right. So we have partial derivatives which are calculating further values of first order, second order, and third order. Okay, so if we just take a kind of an equation, I will just move to a fresh page so that it becomes easier for you to understand. So if I take a kind of a say for example we take a notation, we take a kind of an equation. Say for example, let me write it like this. We can write as z equals to 2x squared plus 3y to the power 4. Right, so this is a kind of an expression. So to get the if I take the partial derivative of this part, so what I'm going to do is that I'm going to take the partial derivative of z with respect of x. So how will I do? So I will write it as partial derivative of dz by dx. If you are unable to understand, you can omit this part, because this is just to show a kind of a idea. And if I do this way, I get dz by dy equals to it would be 12y cube, right? So what I'm doing, I will just try to circle it otherwise with a different color. So what I'm doing is that I am in this part, right? So in this part, what I've done, I've taken the partial derivative partial derivative of z with respect to x, right? And this part, what I have done is that I have taken a partial derivative. This part is basically the partial derivative of z with respect to y. So both of these cases, see, the partial derivative is taken of z. That means we are taking one, and we are taking one in x, and we are taking another in y. Now if you see, if I want to do a further, in order to get the second order derivative, which I have shown you that it has got a first order, then we move on to the second order, this one, first order and then the second order. So for the second order derivative, we can take the derivative of the first order derivative. So this part can be written in this way. So what I can do is that I can write d squared z by dx squared equals to 4, right? And then we do this part, so we get d squared z, and here we write dy dx equals to 0. Then we proceed with this part, and we get two values. We get d squared z by dy squared equal to, this part equals to 36y squared, right? I'm solving for this. And I also get d squared z and dy dx equals to 0. So you see that what I have done is that from this particular part I have taken these two independently, and this particular part I have taken these two independently. So this is the first order, and then we got the second order derivative, that is raised to the power 2, right? So now we will come to the part which we are concentrating, which is called an ordinary differential equation. So ordinary differential equation, what we have seen is that ordinary differential equation is basically in this way. So linear, separable, homogeneous, and exact. So how does a linear ordinary differential equation looks like? So this is, I can call it as linear ODE, right? So we are taking a linear of ODE. So it would be something like this. It would look like dy by dx equals to px y equals to, sorry, this would be plus pxy equals to q of x, right? So here p and q both are functions of x. Both p and y P and Q are functions of x. Now let us quickly see an example. So for example, if I take a kind of a equation like this, let me use a different color. So if I use y prime plus 2xy equals to x. So what is this particular equation is ordinary is a linear ODE. So here I can write that P of x equals to 2 and Q of x equals to 2 equals to x. I'm so sorry. Yeah. So in this way, what we can do is that this is already in the form of a ordinary differential equation. That is a linear ordinary differential equation, right? P of x 2 and Q of x equals to 2. So it is already in the form of a ordinary differential equation. So what I was so this actually is already in the linear ODE format. This is this format, right? So we are done with the linear equation, differential equation, first order differential equation. So what we are left with that what is called a separable differential equation. So just let us look into this. What is a separable ODE? So if you look into this, a separable ODE, if I talk about that, it generally looks something like this. This equation will be separable ODE would be, dy by dx equals to 2x by y, right? So this is a typical format of a differential, a separable differential ODE, ordinary differential equation. So it might happen that your entire equation is not exactly in the format, but you can get to this format. That is also nice and fine. So what I can do from here is that I can even write that dy equals to 2x over y dx. And if I multiply both sides by dy, so I multiply this side by dy and I multiply this side by dy. So if I multiply both sides by dy, right? So multiplying both sides by dy, what it comes is that it shows like so it would be, this would cancel out. So y dy equals to 2x dx. Now you see, is a typical, I would kind of a nice observation. Now what we get over here, from what we get over here, this part if you consider, and this part if you consider, so this is basically the y part, multiplying by y, and this is the x part. So this would be the y part, and this would lead to x part. Right, so that means that it is separable. So this is the y, this is the x, this is a kind of a separable differential equation. So what it becomes clear from this equation is that we can get hold of these two separate parts, then it is a separable ODE. So also what I would like to keep a small note on this is that if we are using a kind of a equation like, say for example, y equal to 2x plus 4, right? And if you're doing the differentiation, so dy by dx equals to 2, and it can be also written as y prime equals to 2 because there's a first order derivative which we have seen earlier, that you can call this as y prime and y prime prime. So therefore from here what we can do is that we can write dy equals to 2 dx algebraically if you can do. And this is also a kind of a separable differential, ordinary differential equation, because this is something for y and this is something which we get for x. So solving this kind of a equation, we also get what is called a separable ordinary differential equation. The final part which remains is what is called a exact ordinary differential equation, but we are not going to look much because it will take the form of integration in order to know that. So what I'm going to do is that I'm just going to write the form. We can look into it later. So it would be mxy plus nxy dy by dx equals to 0. This is what is a typical way of writing a exact differential ordinary differential equation. We are not going to look much into this because in later I will make up a video in which we can deduce and find out the different conditions of ordinary differential equation. So for the time being, what we can do is that we have almost completed all those things. The linear, separable, or homogeneous, we are not going to look into this video because homogeneous differential equation is something which we'll take up later. So now you see with the first and the second video, we have more or less covered. So we have covered what is an equation. We have seen that it is done with linear equation. We have seen examples in which we are plotting lines and it is coming as a straight line. Different types of equation, we have already seen what are the different types of equation. We started with what is an equation, and this is what is an equation, the different parts. We have seen different types of equation, which is also there in the video. You can watch it in the earlier one. We have done with the notation of differential equation. So the notation of Leibniz, Euler, Lagrange and Newton, we have seen that. Advantages of notation, yes, we have seen that the advantages of notation, how you can use it, because different kinds of notation will have different meaning and how these meaning actually relates in understanding and writing in a proper way, right? We have also seen, if you see this one, we have also seen what is a differential equation. From here we have seen what is a differential equation. We have also seen what are the different types of differential equation. These are the different types of differential equation. So in the next video, what we are going to look forward is the most important and the starting part of differential equation is that how we can find out the order and the degree of differential equation. So I would take a different kind of an approach, a detailed one, and I will go back and I will show you how you can find out the order and the degree. We will concentrate more on finding out the degree, but less time in concentrating and finding out what is an order, because it would be a straightforward approach. So thank you very much for watching this video. If you have missed the earlier part, go to my first video and watch out all those topics listed out there. The final part only covered the differential equation and the different types of differential equation. Thank you very much. Please do subscribe if you like and comment, and if you have anything, any feedback, do let me know. Stay safe and stay happy, and bye for now.